this video on special parallelogram properties. First, we're going to talk about the four special parallelogram properties. First property deals with rectangles and squares. And it says that the diagonals in a rectangle and a square are congruent. So the diagonal from A to C in each of these diagrams is going to be equal to the diagonal from B to point D. So in any rectangle or square, those diagonals are congruent. Property number 2 says that all sides in a square and rhombus are congruent. You probably knew that about a square. Now you know that about a rhombus as well. All four sides are the same. Property number 3 says that diagonals in a square and rhombus are perpendicular, meaning they cross at a 90-degree angle. So when we have the two diagonals, they meet in the middle, and all four angles in the middle are 90 degrees in both a square and a rhombus. Property number 4 says that diagonals in a square and rhombus bisect opposite angles. So in this square, if this angle is 90 and this angle is 90, the diagonal is going to cut those angles in half. So half of 90 is 45 degrees. If we had a rhombus where we knew these angle measures, now it's not always going to be 80, it's not always going to be 100. In a square, it will always be 90. But a rhombus, those angle measures can change, but the same can be true. The opposite angles will get cut in half. Let's get to some problems. So we need to solve for the missing variable and find the missing measurements of the rectangle. So let's say we were given that segment AC, this diagonal, is 2x plus 9, and segment BD is 5x minus 12. We can use property 1, saying that diagonals in a rectangle and square are congruent. So AC is going to be equal to BD. So we take the expression for AC, 2x plus 9, set it equal to the expression for BD, which is 5x minus 12. Now we need to solve for x. So we subtract 5x on both sides. We're left with negative 3x plus 9 equals negative 12. Get the negative 9, move the 9 over by subtracting it. We're left with negative 3x equals negative 21. Divide by negative 3 on both sides, and we get x equals 7. So that solves for the missing variable. Now we need the measurement of AC. So we replace the 7 for x, so we get 2 times 7 plus 9 tells us AC is 23. And we can do the same thing to find BD. Plug the 7 in for x and confirm that BD is also 23. If we get the same result for both, that tells us we solved for x correctly. Next example. Let's say we were given the side lengths for a square. Well, again, all sides in a square and rhombus are congruent, so we would set these equal to each other and solve. I want to give you an example of utilizing property number 2, in which this is how we would do it. If you would like to solve these examples and check with Mr. Ryan, you may do so. Using property number 3, diagonals in a square and rhombus are perpendicular, meaning they cross at 90 degrees. So if we had a square, we've got a 90-degree angle. All four angles are 90 degrees. So we can take this expression, set it equal to 90 to help us solve for x. And in this case, x would equal 14. Solve for each missing angle in the rectangle. So a couple properties to remember. Diagonals in a rectangle and square are congruent. And property number 5 from our parallelogram properties says that diagonals bisect each other, meaning that when they cut in half, they are the same length. So in a rectangle, we need to remember that all four angles are 90 degrees. So in a rectangle, that doesn't get split in half, but the two portions are going to add to 90 degrees. That's something to keep in mind. So if this is the only angle we're given, and we need to find all these other angles, knowing that the diagonals are equal and they bisect each other tells us that all four of these sides are equal. And by marking that, we have now created an isosceles triangle up here, as well as an isosceles triangle on the bottom. Now you can see the triangles in green. Those are also isosceles triangles, meaning that in an isosceles triangle, the base angles are equal. Another property to remember is that vertical angles are congruent. So if I wanted to find angle 1, the first angle I'm going to use is, well, angle 1 is vertical to that 102, so that's going to have to be 102 degrees. Then, knowing that the base angles have to be the same, and all three angles in a triangle add to 180, I can take 180, subtract 102 to get 78, and I know in an isosceles triangle, these two angles are going to be the same. They have to add to 78. So if I have two angles that have to be equal and add to that number, I can cut it in half and tell me that each angle is 39 degrees. Now we have the exact same isosceles triangle up top here, so angles 6 and 7 are both 39 degrees. Now from here, I'm going to isolate one of these corners, because I remember in a rectangle, the corner is 90 degrees. So if this portion's 39 degrees, we need to figure out what this portion is. We can do that by taking 90 and subtracting the 39 of what we have, which tells us that this angle is equal to 51 degrees. Now, if that angle is 51 degrees, its base angle partner, angle 9, is also going to be 51 degrees. We have two of the three angles in a triangle. If we add all three, it's supposed to get us 180. So we can take 180, subtract 102, which tells us that this top angle is going to have to be 78. Now this green triangle is exactly the same. These angles are vertical, means that angle 3 has to be 78, and the base angles are going to be the same. They have to each be 51. Now, solving for angles in a rhombus, we have to remember that the diagonals bisect opposite angles. So if they get cut in half, well, if I know this angle, well, I kind of know this angle. It gets cut in half, so it must be 42. And the same can be set up here. Now, remembering property 3, that the diagonals are perpendicular, means in the middle, I've got four 90-degree angles, in which I have four triangles. They're all right triangles. I'm missing the third angle in all four of them. So all three angles in a triangle add to 180. So if we added what we have, subtract it from 180, we'd be left with 48 degrees for all four